In this chapter we're going to model our wooden door complete with planks. So what we want to do is for our door itself is to create another null, and like I just said, we'll pull it off the door frame here. So I want to go to where we had the poly extrude. Let's pop that over to the null there. And we'll call this just door. That's what we're going to make there, the wooden door. So yep, let's just center on that. So I'm going to add a blast node because I want to keep the inner frame like we did before, and we'll choose our extruded front group. If you remember, on the poly extrude node we made a group extruded front, and that's what we want to sort of remove there. And let's turn on delete non-selected because we want to keep that inner frame. Now I don't want just the inner frame. What I want to do really is keep the top bit here because that's got the width of the door, and I want to create a line again with some dots on it so I can copy a plank model to each one of those points. So I only really want to keep the top face. So again, this topology is not going to change because it's all built from predefined templates. So it's okay for me to grab a blast node, and instead of selecting it this time, actually, let's turn that on before we delete it. We can turn on the primitive numbers, and we can see it's primitive number 2. So in this blast node, we can just put in number 2 and hit delete non-selected. So instead of groups, you can actually specify which component you want here. In this case, the primitive. So that's kept the one that we want there. Now, what I want to do is have a line go up the center of this. So there's a couple of ways we could do this. We could scale it down and fuse the points, or a few things. I'm actually going to use the poly split again. So I'll use the poly split tool. Where is it? Poly split. Here we go. And to use this tool, you hold your cursor over the viewport and hit enter. And then remember, you can change the mode to edge loop, and then you'll see the center point there. You should be able to snap to it. And then when you click, you get your center loop, and then you can turn this on to grab that, to turn this on so that new line is in its own group, and then another blast to remove everything except for that group. So we'll select our split path group here and do delete non-selected, and you'll see it just leaves us with the 2 points. We actually need a line there so we can resample it. So to join that up, we use our good old friend the add sop. This will allow us to join points together. In this case, I'm just going to go to polygons and turn on the group here, and you'll see it just joins all the points in their point order to make a line. And then what we want to do is resample this line for the number of points that we want for planks. So I'm going to add my resample, and we'll have, say, 5 planks. There we go. So each one of these will represent a plank. Now, let's see this in relation to the actual frame. I'll template the frame. So at the moment, that's at the top. Now, if you remember, when we copied our bricks and walls and things, we actually used the points at the bottom here on the floor, and we copied things with the pivot on the bottom of the floor. So what I want to do first of all is just make my plank model. So let's create a box. We'll call this box plank model. And what we want to do is we want to know sort of how high this is going to be. So we don't know the height of our box. Let me template the box here. We don't know how high it's going to be, and we don't know its width either. Now, what I'm going to do is I'm eventually going to copy this guy to these points, and if you think about it, he's basically going to be the width of each one of these segments, really. So I want to find out sort of what the width of the segment is, and use that to find out how long those planks should be. So one of this width, one of that width, etc., etc. So how can we do that? What I'm going to do actually is I'm going to create a polycut node, and I'm going to feed that off this resample. Now when I turn on the polycut, at the moment you'll see we've got a 0, 1 0 for the whole curve here, so that is just one primitive. Now with the polycut, if you set this to cut and you set the cut points to star, which means everything, it actually cuts this up into individual edges. So now we'll see between each point is its own primitive. So this is all separate pieces now. If I turn on point numbers, you'll see we've got duplicate point numbers on each point there. So now we've got 1, 2, 3, 4, 5 primitives. Now we can actually use a node called the measure SOP, and the measure SOP will allow us to measure things about the geometry. And this is really useful for doing procedural things. So we're dealing with primitives here, and we can measure their actual perimeter, which is the length of each one of these. If I bring up this spreadsheet, let me just middle click and bring up the spreadsheet, click on primitives, you'll see there we go, we can see the perimeter, so the length is that. So we know this is the width, that's how wide we want each one of our things to be. So I'm actually going to branch this off from the network and create a null, and I'm going to call this measure out. So this is where we're measuring stuff. So in here now, instead of I'm going to write an expression here to read this attribute. Now if you look, this attribute's a primitive attribute this time, not a point attribute. So I'm going to use a primitive expression, whereas before I used a point expression. And I'm not going to type the path. Like I said, I like it easier if I make the spare input. So I'm just going to do that from now on. So I'm going to click up here, create a spare input, and then I can just drag my measure out there. And now I can refer to this as -1 in the expressions that I write. So the first expression I'm going to write here is to find out the width of the box. And to do that, that's this size here, the size x. I'm going to use a prim expression called prim, and what that will do, it'll allow me to read a primitive attribute, whereas before I read a point attribute. And look here, we give it the path, the number of the primitive, the attribute, and the index. So we know the path is -1. We know it doesn't matter which one I read, they're all the same value, so we'll read 0, we'll read the first one, and then we want to read in our attribute, which is perimeter. Got to spell that right. Perimeter. There we go. And then the index, there is only one number, so it's 0, and then we can fire that off. And if we look now, we'll see, if we return the number, that's returning to 1776, and look, it's the same width as each one of these curves there. Now we need to know the height. Now if we look at our measure node, we'll see it's got a 0 height there. But we don't need to worry about that. If we look at where this is in relation to the door frame, let me template that, we can see that our curve is actually at the top of the frame. So its y position is the height from 0 to the top. That's how high it needs to be. So again, if we look on here, we can see the maximum y is this, 1.44. So that is the actual height that we need. And so we can read the bounding box. Now in here, I can't use my $y_min or $y_max because those are what we call local variables. And the local variables only work for this particular node. So that would be the bounding box of this node. So I can't use those. So I'm going to have to use another expression similar to the ones that we've typed here. So instead of point to read a point attribute and prim to read a prim attribute, we can actually use another expression called bounding box. So you can type BBOX. You'll see it auto-completes as you do. And if you open the brackets, it gives you the help. So there's an equivalent to find the centroid. So if you weren't able to use those variables I showed you, $y_max, $y_min, or $CEX, then you could use these expressions instead and get the same data. Not all nodes have those local variables though. You can find that in the help. So here I'm going to use bounding box, and again we're looking for the node, the path, and the type here, and these are the types I want. So I want d_y_max, there it is, d_y_max. So we can put in our -1, which again is referring to this node here, the measure out, and then we'll do d_y_max. Now if I just template my little box here, we'll see that's returning 1.44, and you'll see now the right width and height that we want him to be. Now we want to make him, let's put 0.05 in for the depth there, so it's a tiny little plank. You can see it in the template there. So now that's constrained to our plank. So if I go to my resample and I change the number of planks, you'll see our model gets thinner to accommodate that. So it will always fit. Let's have 5 planks for now. Now, to get this to copy correctly, what we want to do is I want to place my object here on the grid. So here's pivots at the base. So we'll add a transform node after the little plank here. And we'll type in our $$ymin. So he jumps up to the origin. He aligns himself to the grid there. And if I look at my resample here, I want these points to be on the floor, so that his pivot on the base will match the where the points are. So again, we can use the same transform node. If I just copy that over with holding the Alt and left dragging, I can just plug the resample in, and that will also take those points to the floor. So now our points are on the floor, and our guy's on the floor. He'll just copy over and sit on those points. So if we add a copy to points node now, there's our copy to points, there it is. So we'll plug our plank in, we'll plug our points in, we'll now see our plank sits up on the floor where we want it to be. And if we template the door frame, you'll see it sits nicely within the frame. And again, we can add a transform. Actually, we'll move him forwards at the end. I'm not finished modeling. You will notice actually he's sticking out the edges here. So what we really want to do is we need to remove those extra bits, and for that I'm going to actually use a boolean. So what we'll do is we'll just make a boolean. Let's just hide that for a minute, and we'll subtract off our original doors here. So let's click to the null at the top, the original door frame, and we'll plug that in, and you'll see it's booleaned out the door frame, and it's cut out the bits that we want on the inside, but we don't want these outside bits, so that we've got smaller planks at the edges to make that fit, which is quite a nice effect. Now actually this line going across, we can actually hold down Alt and left click and drag in the line, and look, we can pull out a dot if you want, just to make that slightly easier to see what's connected if you don't like all your networks getting all funky together like that. So you can use these dots to help spread things out, and you can connect to those as well. So we'll just put the measure over there. Just make that a little neater. Cool. So how are we going to remove these bits? Well, again, I'm going to use a group, so I can define the bits I want to keep and the bits I want to get rid of. And this is another nice way I like to use groups, which is quite procedural. Again, this might change shape. So what I'm going to do with the group here is, if we set this to points, and we can, what should we call this? We could call this keep. What I'm going to do, I'm going to select a bunch of points that I want to keep. So they're going to be, what we're going to use is the bounding box method. So let me turn this off and turn on bounding regions. And what you could normally do is draw a bounding box and move it around, this kind of thing, and anything that's inside the box, let me just move that forwards, will be in the group there. Look, can you see they got highlighted when in the group? But this doesn't know about the shape of the geometry. What's nice is we have this second input, a bounding object. And look, we can change this to a bounding object. And look, it only works for points, which is why we want a point group. So what I like to do is I like to add a bounds node again. So again, we'll feed that off this same little button here. Look, I can just drag that off. And if I look at the bounds, let's just plug that straight into the group. There we go. And we can see the bounds node has now matched the shape of the original geometry there. So there's our bounds group. If we plug it into the normal group, you'll see it's there, and it's just missing those outer points for us, which is quite good. So we can just affect the padding here. So let's look at the lower padding in X. You can just bring that in slightly, and the lower padding in Z as well. Just bring, sorry, the upper padding in X as well. Let's just bring that in slightly, just to guarantee we have those center points. And I'm going to lower the lower padding here in Y, just so I get, and the upper padding in Y, just so I guarantee I'm getting all those middle points there. So as you can see, if we go back up to the original, where's the door, all the way up here, if I change the door width or the door height, that bounding box always updates and always selects the bits that I want. So it's quite handy to use bounds in this way through a group. So again, I might just create another little button just to make that look neat. There we go. Let's move that in a bit closer. Cool, so it doesn't matter the size that we use, we've got our group. So again, we'll use a blast in conjunction with the group. So on the blast here, I can select my keep group and then say delete non-selected. So I've kept those inner faces now, which is all very nice. So what I'm going to do now is I want to loop through each one and extrude, poly bevel them separately so we get our nice little edges on each plank there. So that's quite straightforward to do. We can do for each again and choose for each connected piece. Just plug that in. And then we can add a poly bevel quite simply inside the loop. And this is going to go through each connected piece, which is each plank. And look, if we adjust the bevel, you'll see it bevels each one independently for us. Let's do another level of 2. There we go. So we've got a nice sort of soft look to our planks there. Now that seems to not be working very well, so what I'll do actually is we'll use an assemble node, which is quite good at partitioning these bits up. What we'll do is we'll delete the connectivity node, because that's changing it. And we'll change this attribute to name instead. That's still not quite separating them out. Let's do an exploded view to find out why this is not separating them. See, they should be seen as separate objects there. So we've got our copy to points. It's interesting. We're just exploding them. Our boolean is seems to be messing that up for us. So what we can do is we can actually clean up our topology here before we plug it into the after the exploded view here. So let's actually let's do it before the boolean. So we want to consolidate the points, and we just want to we notice we get an error of non-manifold geometry, so we can say manifold only topology but keep the small patches, which should there we go, fix our issues. So if we now blast off those bits and assemble, yeah, the exploded view still works, and we look at our for each now. There we go. Now we're looping quite happily through each one of those. So I'm not sure why the copy was creating dodgy topology there, but yeah, anyway, we can just clean it up by this is basically fuses the points together. So we still have the same number of points, but it's the non-manifold bit that's important there, and that will allow us to then create the assemble and our loop. And now we can, as you can see, poly bevel each one individually. We get our nice sort of looking planks there. So let me just tidy up this network a little bit. Let's just where did that come from? Let's just pop that in a bit closer. Let's make these a little neater. And so let's have a look. So yeah, let's delete this extruded front group with a group delete node. And then we'll just delete any unused groups. And oh, did that get rid of it for me? No, it didn't. Just let me just reselect. There we go. Extrude front, and we don't need the keep group either. So we just want our attributes here. Then we'll create our UV unwrap. So we've got some nice UVs on all of those. So again, we'll add a quick shade. So just to show the difference here, again, if we do that, we can see we've got UVs that way, but if we put them in the loop, we'll UV each one individually using the same projection. It's up to you where you want to put that in. You could add some variation per loop on the projection, just so you've got a different UV layout on each one if that's what you wanted. I'm then going to create an assemble node again afterwards. This will overwrite the old name attribute, but we'll call this door. So we'll know that it's the actual door itself. And then we'll create our new group. We call this door. I'll just copy that name. And then like we did before, we'll just recalculate the normals as well. Let's pop that in, say here for example. And then we'll create our null at the end. And I like to call this door out. There we go. So we've got our nice little network there creating our planks, our wooden planks. So if we just make a net box, we can call this door there. Let's give that a dark browny colour. Why not? And again, we can connect our door to our merge, and we can preview our door in situ with everything else. Just give that a second to catch up. Again, you may have faster machines than me. You may see that work quicker. So there we go, we've got control over the door and stuff. And the last thing you might want to do actually is, after all of this, is just pop in a transform node. So you can move the door in relation to the frame. Remember, if you hit enter, the pivot will be at the back. So in pivot transform, we can type our $CEX for the centroid in X, or $CEY for the centroid in Y, and $CEZ for the centroid in Z. And if you just reselect that node, you'll see the pivot snaps to the object itself, and that we can move the door forwards or backwards in the frame independently if we want to. We can control it that way. So let's just move it forwards a little bit, something like that. Maybe it's slightly back, I don't know. Excellent, but as you know, we can change everything, the door, the shape of the door, the height and everything. I won't demonstrate it because it's quite slow, but our house is slowly getting there. So the next thing to do really is to start to build the roof. And again, as you might have guessed, I'm going to build it off the existing geometry that we already have.